Alright, so I want to clarify a little bit on the assignment because I'm still getting people asking me questions. So on the first exercise that we did, you do not need to install Oracle to do the first exercise. And if you look at some of the exercise questions here, it says, whoa, in your locally installed Oracle version. Ignore that statement. Ignore that statement. Instead, list all the files that are available in the user's system and whatever, tables, whatever. Answer the questions as generically as possible given the Oracle install, which means you'll have to go through the PowerPoints, those little Oracle Essential lectures, or you'll have to do an internet search. It's sort of a scavenger hunt activity. And what you're going to find when you start looking at the information is that some versions stored all the log files in one. Some of them used a lot of control files, some of them didn't. So try to provide enough information in your answer to justify why you're saying what you're saying. So if you're, for example, and then also all tables, the current version lists all tables available. The current version has like over 200. Don't list all over 200, or list maybe 5, 6, a handful. The idea is you're trying to give me the impression that you went through and actually looked at this stuff. So the answers that you're giving me are not right or wrong because it really depends on the version of Oracle. But don't worry about installing Oracle is what I'm saying. In fact, when you install Oracle, you're still going to have the same problem and you're still going to go out to the internet, you're still going to look for this stuff or go through the essential lectures because you're not going to be able to find the answers easily either. So it's not really going to even help you at all, seriously. So that's what this first assignment's about. The second assignment we're going to do in about another hour or so. And in between, I'm going to start a new lecture for you on creating and modifying database objects. So it's the enhanced guide to Oracle. So what we're going to do now is take a look at some of the things, and I'm going to explain some of the items that you did in that first exercise on your scavenger hunt so you know what it is you're actually doing, what it is you're actually looking at, which might make a little bit more sense in the long run. So we're talking about Oracle that is based upon database objects. And by the way, this is lecture, what lecture is this? This is lecture 2B. 2B, if you're downloading, or, because some people don't want to look at that screen, you want to look at it on your own computer, it's number 2B from the bhacker.com website or from the LMS. It's also in there as well. So the Oracle concept is based upon the concept of the object. And so, although we're not looking at an object-oriented database, we're looking at a relational database. It still works with database objects. So when you install Oracle, if you ever do, what you're going to end up having to do is create an object, and that's going to be the user object for HR or for engineering or for management, whatever the department is or the organization or the person who's going to be using this object. It's going to identify it. And then you're going to create items inside of the object. And the items that you're creating so far, we've talked about tables, a lot about tables, because that's the whole concept of entity relationship diagramming, is to develop the methodology so that you can create the tables inside of these objects, which is the main part of databases if you think about it. But the Oracle object also consists of multiple user accounts. So we have user accounts, so the user account owns the database objects, and inside of the user account we have what's called the user schema, or the user scheme, which is why that word is used in this context. And most people from the first exercise from yesterday are still wondering, well, what's a scheme? What's a schema? The user schema is a component that, in the old days, there was a tool that you could select and it would actually show it to you. And when it showed it to you, it looked like an entity relationship diagram. So inside the schema, we've got not only the entities that are represented as tables, but the lines between the entities showing us the key relationships. The schema actually includes the keys, the relationships, the components, the views, the privileges, all that stuff actually. The configurable information inside of that object is part of the schema concept. So the word is actually used in a lot of different contexts. So if you go online and you search on the word schema, you're going to hear a bunch of stuff about, database schema, user schema, person schema, I don't know, account schema. It's just a generic word to say configuration. And that's just one of the kind of definitions of it. So it's kind of an interesting word used a lot in database contexts, often misused. So don't stress on the differences between the different schemas. There's a lot of controversy and there's a lot of contradiction between what people call everything. In terms of the database objects, we have tables, views, stored procedures. We have a bunch of stuff that's stored inside of the object outside of just the table structure. It would be way too simplified to actually consider the database just the tables. And then we have database querying. So later this afternoon I'm going to start, and then tomorrow is going to be all about SQL and querying. So I'm not going to hit you with too much of that stuff today outside of the introduction, but in order to understand what we're doing here, querying, or the queries, the commands that are going to be performed for operations on the object. So when you actually do install Oracle, eventually, if you do it, you don't get anything. You get a database. And it's a server engine that runs on your computer, and there's very little client support for it. So there's no program you log into, and well, there's a web interface to this, but there's no real application that you're using. Instead, what you're doing is you're using SQL to create tables, populate the tables, query the tables, and it's all about SQL commands, and it's all about table construct and design. So to use Oracle depends on the version of Oracle that you're using as to what features you're actually going to get. The base system doesn't come with very much. The Express version doesn't come with very much. What's expensive is all the add-on products, the report generator, the form generation designer, all these different Oracle products that you install. And then if you want to learn the products, then you actually pretty much just should go to Oracle School, and they'll teach you all about their products and how to use them, because it's kind of complicated, actually. It's sort of like learning PeopleSoft or something, or actually it's kind of, well, PeopleSoft is worse than SAP. But long story short, it's not something that you're probably going to want to even take a class in. It's something that you're probably going to want to pick up and learn on your own as you navigate through the system. But it's like almost the differences between learning how to write a research paper and then learning how to use Microsoft Word. If you know how to write a research paper, you can use Microsoft Word, you can use OpenOffice.org, you can use Notepad, you can use anything. You can use your hand and a piece of paper and a pen. It's the writing the paper that's more important. So that's why you don't have to install Oracle for this course. I don't care if you know how to use Oracle. In fact, 11G is great. Another year from now, we're going to have 12G or 13G or 14G, and it's going to be different. And, you know, everything's going to be really changed in terms of, you know, the clicking and the adding, and it's going to have support for different operating systems and yada yada. But you still have to know how to create a table schema. You still have to know how to create keys correctly and how to implement views. And so that's the stuff we're really focusing on, is how to use it in terms of designing a database with it. But this lecture goes through some of the Oracle features for you, however, and fills in the blanks a little bit in terms of stuff I haven't talked about yet. So creating, modifying, and viewing and deleting objects and components. You can create a view, you can create an index, you can create a table. All of the database objects are all creatable through SQL. So you don't even have to have any GUI at all. But most people don't like command line prompts. So they buy or they download and they use open source GUIs. And the GUIs have you drag and drop and stuff and create components. Underneath that, it's kind of like a higher level application generator that's running an SQL command for you automatically, so you don't have to type the SQL command yourself, which is how that's working. So we have the structured query language for relational databases. As I mentioned before, we have the data definition language and the data manipulation language. I'm going to kind of skip through some of the stuff I've already covered. So there's a little bit of overlap with this lecture and some of the other stuff I've given you. DDL, you know, is used for creating and modifying structures of the database object, to alter a table, to drop a table, to create a table, things of that nature. So the DDL commands are executed as soon as they're issued, and you don't need to explicitly save the commands or use them. DML actually is done usually through applications that are connecting to the database that are running a command, and it's usually done over and over again, so you want to save them. So you put them in scripts, you put them in files. So it's used to insert, delete, modify the data itself. And when we talk about DML commands, we talk about rollback and commit. So most people from a generic thing have heard of the concept of committing and rolling back if they've used databases before. Important to notice though, the DDL commands don't play a part in this. There's no history, there's no log, there's no control, nothing associated with this. Okay, 1 second break. Anybody not sign the attendance? Anybody come in and not sign the attendance, raise your hand. Okay, you're all in the attendance, thank you. We're done with the attendance. Thank you. So we're all done for today, actually, in terms of attendance. All right. So, does this guy sign the attendance? The guy, as soon as I do that, one person walks in. It's kind of ironic. Did you sign the attendance? All right. So the commands are explicitly saved for rollback and for commit. So in the SQL window, if you you install Oracle, you'll find you'll have a run SQL command window, and in that particular window, you'll have a history that's being saved. It's actually in the form of a log file. So all of your commands and everything that you're doing is logged so that the database can reverse itself. Only works with DML commands, does not work with DDL commands. If you drop a table, you've dropped a table. If you've deleted, if you've created a table, you've created a table. There's no undoing that. So a lot of people are kind of led to believe that everything is undoable. Not everything's undoable. So it's, and actually we have a certain set of DDML commands that are completely undoable. As an example, truncate, not undoable, ever. And we'll get into those commands probably more like tomorrow-ish when we start looking at SQL commands and stuff. Which is another misconception. SQL is SQL. It's a standard language that's used everywhere. Every database uses SQL. Then we have SQL Plus. The plus, it's usually asterisk and a plus for Oracle. Those are Oracle-specific SQL commands that are written for the Oracle interface and only work on the Oracle interface. The plus commands don't work anywhere else. So when you do install Oracle and you take a look at the command line interface, it'll say SQL Plus command line interface, which means all of the Oracle commands work in there. Also works in there is PL SQL. So there's a procedural language that works with SQL, written by Oracle, still supported, still being used, to write lightweight scripts that enable you to take SQL commands and stick them inside of a scripting language and not have to use another language for it, and then run it right there in the SQL Plus window. So kind of automates things a little bit easier, a little bit better, makes it so that, you know, I don't know, more integration with the scripting language and also the SQL statements. Because right now you take a scripting language, you take a programming language, and you have to make special effort to include outside commands into that, you know. Run this query, run, you know, and then take the query results and parse it and put it into this, but tedious. So PLSQL is not too bad, but it only works with Oracle. It only works with the Oracle SQL Plus window, which means you can't like put it out on the internet. So it only, there's an internet version of it, not so good. So internet scripting languages are a lot better way of going about, like using PHP or something like that. Actually, PHP is really cool because most companies use, or most people I should say, use an open source utility called PHP admin. Works with Oracle, works with MySQL, works with every client server kind of database that's out there. It's a PHP program where you can create tables, drop tables, do stuff with it. That's a much better interface than Oracle, actually, when you think about it. Because Oracle's not going to provide you with that kind of level. That's an open source utility. So if you're interested in learning anything, learn PHP admin, actually, and how to navigate that. If you sign up for a web account, you know, you get an ISP that gives you Oracle access, or usually it's MySQL access because that's free. Same capabilities, same scripting language, same, everything's the same. It's just a different, you know, it's not by a for sale company. It's by not by a nonprofit. I mean, it's an open source utility. So each Oracle database user has a user schema. To answer that question for you, here's a little bit more information on the concept. It's part of the user account, so areas in the database where the user's database objects are stored. This schema includes all of the objects outside of just the tables and the schema of the tables. Identifies by a unique username and protected by a password normally, and each user schema is granted specific privileges. So we have different levels of privileges on objects, and then objects are owned by users. So here's yet another definition of the term user schema, if you're still looking for stuff on that. And then we have this concept of privileges. We have object privileges and system privileges. So everyone from a Unix, you know, background knows admin has all the privileges. Well, in Oracle they call them system. Why do they call them admin? I don't know. There's a system account. System is the admin, and system has all of the everything, power over everybody. So system privileges control the operation of the users, which ones they can perform within the database, and connecting to the database, creating tables, shutting down the database, all those things. Think of it like an admin for Unix. And then we have object privileges, so we can grant objects, individuals, access to certain objects that are owned by them. Well, they get automatically if they create them, but they can also add privileges to objects that aren't owned by them. And you can also grant privileges to views of objects, or views in general, or indexes and other things that aren't owned by them. You want to do that so you can share information globally across the entire network system. And then not ever have everybody giving access to everything. Instead, you grant to on a particular group or privilege level, so you can create profiles just like Linux or Unix. You can create user accounts with profiles, with privileges, and grant and revoke privileges all over the place. So controls operation that the user can perform on specific objects. Also, you can create an object in your user schema and can grant privileges to that object to other database users. The HR department is a pretty good example of that, because HR people are the ones who own the objects. But you're normally able to come in and look at your information if you're using one of those HR self-service systems. Check out how many late days or missed days of how much vacation pay you have and stuff like that. Look at your annual reports and stuff. But you can't look at everybody else's, just yours. And you can't look at everything in the HR database, just your information or just your objects. If you did, then you'd be able to give yourself a raise or something, but that doesn't normally work to anyone's advantage. So, alright, so we have the Oracle naming standard. So when we create the objects, the Oracle databases must adhere to a naming standard where we have 1 to 30 character long names, begin with a character, kind of a standard character. In fact, these are the same things that we get for tables. So the objects themselves, the views, the tables, the indexes, all the different components that we can create inside of Oracle have to adhere by this naming standard, which means you can't start out with a number. It must be a character. And which is kind of the similar kind of naming convention a lot of programming languages have adapted to. So if you're familiar with C or C++ or Java, you can't start a variable out with a number. It has to be a character, and you can only use certain special characters in the name itself. So if we were to take a look at this window here, this is a classic example without even installing Oracle. You'd have this, so you'd go to the startup menu and you'd hit startup, you go to Oracle, the program files list or whatever, or program menu. And you'd hit Oracle SQL Plus. This is what I was talking about. Oracle SQL with an asterisk plus. It means plus, which means and then you basically get something that looks like a DOS prompt. So this is what the window looks like. And it's usually done by the DBA to create accounts, but you would actually, believe it or not, use this window to do everything. So you don't actually have a GUI. By default, you don't really have a GUI interface to anything. You will always have this, which makes it nice because then you're a DBA and you're at home or you're in Texas and the database server's in California or something. Then you're just telling it in. You type in SQL, and you actually just connect to the database. You're connected. Then you get this SQL prompt, and you type your stuff in, and you start working with your stuff. So those people who loved DOS commands or Unix commands love this environment because it's really quick and easy, and you can do everything. Very powerful. Everything you can do for the database you can do through here. Here's a create user L Howard identified by this password here. And this password is just kind of a weird password, and then it comes back and says user created. Great. So that's an example of running a command on a database system. So examples of Oracle privileges. I think this may have been even one of your questions. I'm not sure. I know it's coming up in some exercise. Slide number 11, lecture number something. So what do we have? We have create session, create table, drop table. One of the interesting things is kind of similar to Unix, where Unix we have different levels of read, write, and execute for group, user, outside, or global. Here it's not kind of necessarily broken down by access level, it's broken down by utility. So these are examples of privileges that you can grant for users to say, you have the ability to connect to the database, or you don't have the ability to connect to the database. Or you can create tables in your current scheme, or you can create tables in everybody else's schemes. Or you can drop tables, or you can do all this other stuff. So I'll leave this as a reference, creating tables, deleting tables. These are all things, privileges that fall into different categories, and then we have different levels. So we have a user level and a DBA level that we can assign. And those are profiles. And the DBA level is going to have certain things, privileges that are assigned to certain DBA concepts that need to be executed. In terms of granting system privileges, it's usually done by the DBA as well. And here's a grant. Grant create session, create table to L Howard. And then it comes back and says grant successful. So this is your user interface, essentially. This is what you get. So no sense in installing it. You can just look at it right here. That's what it looks like. The only thing is when you start running SQL commands, and what I'm going to do is when you're working on your next assignment, I'm going to set up my access to do it. If you have Microsoft Access on your computers, you can mimic and run the same SQL commands that we're running on Oracle through Access, through a little window, and you don't have to install Oracle. Or you may also install Oracle. It's your choice whether or not you're going to do it. The only reason why I used to in the past require students to install it, and unfortunately, I don't even like it on my computer. It's you're installing a server and a client all on a desktop computer, and it runs about 3 different background processes through system services. And the services are big memory hogs, and your system will run like a snail continuously until you uninstall it. So if you're really going to do it, get a Linux box and put it on Ubuntu if you're going to do it on a desktop computer, and it does not support it on the Mac at all. Or load it on a real server, on a Unix server, and then access it through a server, and don't put the client interface and the server all in the same box. You know, it's meant to be running on a dedicated server, and what you get with the Express version, which is kind of deceiving, you get everything. It's just locked down. So it's installing all of the files, all of the system, which is approximately 8 to 10 gigabytes of, I'm going to call it crap, but it's similar to unusable garbage that you're putting, and you're going to take up disk space as well. And then, well, it's great for learning. If you're going to get a job in this area, install Oracle, because at least you'll be familiar with the tool set. What does the tool set give you? Nothing. It gives you backup, recovery, start the database, stop the database, open up this lovely window. And then you have to know, well, what am I going to type into this lovely window? Well, that's what you're learning in this class, but anyway, it's nice to be familiar with where to find the lovely window from the start menu. So, but that's what you're going to get. Database roles, went through this already. Let's see, an object can be assigned a system privileges, the role. So we have database privileges, we also have roles. The roles are for, generic profiles for privileges. As an example, at ITU we have students, we have teachers, we have staff, we have TAs, we have administrators. We all have different roles, and so when we log into the LMS, which is a database application, you have different access depending upon your role, which is going to give you different features that are going to be available to you. You have a slightly different interface than I have, because you're going to have certain things turned on and off that I'm not going to be able to see. I can't check my grades because I don't have any grades, but you can check grades. So I can give grades and you can check grades. This is basically how it's working. So the role is a database object that can be assigned system privileges. The role is assigned to a user, and then the user inherits the role's privileges automatically. So it's used to easily assign groups of people to different roles. Because what they're not going to do is take every single student in this class and create a new privilege for you. Instead, they're going to assign you to a role and say, hey, you're a student. And then some people actually get students and then TAs, and then you get multiple roles. And then it depends on how you log in or what you're accessing as to what you're going to have privileges for. And there's usually a hierarchy to it. So that's one of the things that DBA is going to do, is do the configuration of the hierarchy, figure out, well, what should these people have to do? Or be able to do, I should say. Or what should they have privileges to, which is a better way of putting it, I guess. But long story short, there's no set standard, and there's no way of preparing yourself for that. Because when you go into the company, I don't know, Google or Apple or ITU, we're all going to have different requirements and a different database. And we're going to have different roles and different people. So there's no way outside of understanding and being able to quickly understand what the company's doing. A lot of it's based upon the company business logic. And so then you're going to create your configuration and create your hierarchy depending upon what you're going to run into in terms of what you're doing. It's not like, it's not like accounting, when there is certain things accountants do that are kind of consistent among all different companies. Database administrators do a lot of different things depending upon what company you're working for. It's not the same job everywhere. So here's an example of creating a role. Here you're going to create a role, Oracle student. Role created. So assigning privileges to a role. So once you create the role, you would assign privileges to the role. So in here we created a role, Oracle student. Now we're going to create table to Oracle student. So if you were an Oracle student role in here, you'd have this privileges and that privilege and that privilege. You basically just string them together, separate them by columns, and these are the privileges that you're assigning. These privileges here. So you can now, create session, drop table, and this is just a handful, by the way. There's more privileges. There's like, as the databases keep getting improved and being expanded, we have more and more privileges that are coming out of this. So All right, so administering system privileges here, being able to revoke system privileges or assigning a role to a user. We did that already. Did I go too far ahead? We created the role, and then we assign privileges to the role, and then assigning a role to a user. So here we grant Oracle student to L. Howard as an example. So it's a hierarchy of 3. Did you have a question? Yeah?
Is it the same even in the reporting side, or is it just applicable to the
This would be for the DBA creating user accounts. And
do you have the same thing even
for the reporting modules, you're normally logging in as a user. And then you're going to have certain privileges that are going to be granted to you as a role for that as well, but it's usually mixed together with the user account. So users, as an example, he had a really good question actually. His question was, are the privileges or the roles the same for the different modules that you're going to run into, like designer, report writer, all that stuff? It depends on your access to the database. If the admin has set you up correctly, they'll give you privileges to use different modules. As an example, you guys as students can't use the backup features and can't use reporting features and can't do anything associated with those that are running through the LMS interface. If you were working at a company and you had access to the Oracle system, you would actually have to be granted access to the report modules and the usages of the report in order to actually run them, because it all is a matter of logging in. So usually what they do with report features is they'll create in fact you'll do this with internet accounts as well. You have an Oracle system out there running, and your website isn't going to log in as a system, and certainly not going to log in as you. You're going to create a generic web login, and all applications are going to use the same login. Yeah, a single sign-on. And the single sign-on for web interface is going to be really restricted. In fact, most of it just does querying. No access to reports, no access to any of the system admin features. For reports, usually you'll have admins or you'll have secretaries or somebody sitting there running reports. Their login will be for reports. And so it'll be a single with a slightly different profile to it because they won't be able to update it all. In internet users, sometimes you'll have to, that single logon will probably end up having to have some sort of an update, but it will be logged. So you'll turn logging on that so you know, and you can roll back just in case you get some hacked, some bot that comes in that creates like 1,000 different user accounts and tries to do something. Yeah. Yeah, actually, good question, good point. There's also ability to create the reports, access the reports, run the reports, modify, so that's all broken down by feature, which is great. And you can actually create your own profiles and your own roles and your own features, and you can user-define privileges as well on some of the packages, not all of them. So, just as you can grant, you can revoke. So here we have a grant, and then we have a revoke. So this is how companies are supposed to do it. Sometimes they do it correctly, sometimes they don't. If you create a hierarchy of users for your company, and you put them all into different roles, you create a hierarchy of roles, and the roles you assign privileges to them, and then you take the people in the company and you assign them a role. All you have to do is revoke the role, and you've locked them out of the system. If you've granted them individually, which you can do, you don't have to put them in a role. Really not planned for companies. They take and create a bunch of users. Oh yeah, privilege this, privilege that, and they give out the privileges per the users. And then they forget about that and they assign them to a role, and then they revoke the role, but hey, they still have access. It happens all the time. Companies leave an employee leaves a company and say, hey, I can still log in. I wonder why. That's because somebody did something, granted you something outside of the role, or did something as a workaround and now it still works. Or what ends up happening is you're a member of a role, but you can't be a member of 2 roles simultaneously. There's a hierarchy of the roles, and one role might be overriding another role. So you'll have conflicting privileges. So you have to unassign, you have to revoke out of one role to use another one, which causes problems as well. So there's quite an art to the configuration of all this. So you can revoke, and here's the keyword revoke that's being used. The keyword grant was being used to give, revokes to take away. So administering system privileges here, to be able to grant system privileges to other users, the user account must have been granted the privilege with the admin option. So you can make any person an admin. Kind of dangerous, actually, because it depends on what you're giving the admin role. So usually there's a tiered admin level. There's a super admin, kind of like Linux. There's a super, and then there's a non-super. So the non-super can do stuff, but can't create or can't grant privileges. Otherwise, you're going to open up the whole system to corruption eventually. So granting a create table to L. Howard with admin option, where, which is going to essentially give them the admin privilege, which is kind of dangerous if you think about it. So defining database tables. To create a table, you must specify the table name, table fields, data types, and the file sizes and the constraints. So tables and field names must follow the Oracle naming convention. Actually, everything must follow the Oracle naming convention. Each table is a user scheme, must have a unique name to it per scheme. So which is the other interesting thing. So the way of creating a nice little backup is to have a redundant system. So you create multiple objects that all do the same thing, and you swap the objects out. So you have an HR object, that's the production object, and then you have the HR test objects. And you use the same table names and the same database scheme in all of these different objects. As long as they're stored in different objects, you can repeat all of that stuff, which means you can have a working in parallel. You can have two objects that are doing the same thing, and you can test back and forth, because the table names are going to be specifically specified or callable by the applications that are using them. So if you have a web application out there and it's going to go into the customer table, well, you just swap the object and you can instantly swap the database out. So a lot of people actually do this for archiving. So you have year number 1, year number 2, year number 3. The database is exactly the same, it's just different objects. So then you can instantly go back and archive through data depending upon what year. Universities do this a lot too, because every 5 years or 4 years, depending upon if you have a master's program or if it's an undergraduate program, you have turnover. So as you recycle through, you have different groups of people. So you probably have noticed this as well when you've gone to order transcripts from schools. They go, what year did you graduate in? And then it goes to a different system because it's in a different database object. It's archived for your year, and it knows which one to go to. If you keep all of that data together, way too much data.
Is it like indexing?
Nah, indexing is a little different. I'm talking about separating data out into different objects. It's identical objects that are interplaced, but they're categorized by year, or they're categorized by, this is the test system and this is the production system. So you can test in parallel. You can archive data this way. You can also have a fault-tolerant kind of system or a redundant system. Classic example, you have one database server and it goes down. What do? Well, you have another database server that has, yeah, clustering concept. Well, you have another server that has the same object, well, a copy of the object on there. It stores up data. When the first server comes back up, you take this data and you merge it back into this data. Or you keep it separate. There's a lot of companies that actually do this for bandwidth purposes. So, like, actually, let's just talk about Google for a second. When you go www.google.com, you're going into a server farm. You know, every 5 times you do it, you're going into a different server. It all looks the same to me. My Gmail is my Gmail. Every time I go into that, my Google search is my Google search. But it's running on about 25 to 30 servers or so. I shouldn't quote that. I have no idea how many. I'm guessing. In California, we have some in Washington, we got some in Oregon, we got some on the East Coast as well. Because you know how far it would be to travel on the internet from the East Coast to the West Coast to the East Coast? It actually makes the bandwidth smaller. And Google it. If you spread yourself out, and this is the same for any company, you know, then when you type in that and it goes to your domain server and it knows where you're coming from, it can pick a server that's closer to you. And if it's going to pick something that's closer to you, you're going to get a faster connection time, which is going to basically give you better quality of service. And at the same time, it's spreading out everybody's traffic over multiple servers, so you're not all coming into one server. So Google never goes down, because if one of the servers goes down, it just reroutes to another. So there's a main system table that says, hey, this server's down. Don't send any traffic to it. And you know when that happens, actually, when the redirect happens, when nothing happens. You type, and I'm sure this happened actually a couple of days ago. They had some issue with, I think it was like some of the West Coast servers were going down. I don't know if anyone experienced. I experienced it a couple times, maybe a couple days ago, maybe Thursday, Friday.
Even Bank of America.
Bank of America does that too. If you type in Google and you sit there and nothing happens, and you go, hey, wait a minute, and then you press go a couple more times or something, or oh, let's just do it again. You can hit the bookmark, and then if there's a little bit of delay, nothing, like a white page, it means it's rerouting because the server's down. The server it tried to go to initially is not available. So instead of telling you, hey, we're down, they're never going to do that. They're going to reroute you. Wells Fargo, Bank of America, they all have redundant servers. So, because you can't go down, but IT only has one server. Well, we're pretty small, so. Anyway, but if you have, going back to the reason why I mentioned this, if you have different database objects, you can clone the objects, put them everywhere, and then merge the data eventually, or you can actually have it automatically synced. And then you're taking a server database and you're really integrating it into server technologies, and you're providing fault tolerance, and then you're treating it like a server, which is one of the benefits you get with a server database versus a Microsoft Access. Can't do any of this with Microsoft Access. It's not meant to run on a server. Although people use it for websites, it's great for small little address book things, but nothing, guest lists maybe, but nothing too sophisticated. Alright, so names and fields. Each field in the table must have a unique name within that table. But you can have different user names for different things for different objects, and they can all be the same amongst different objects. Which brings me to the Oracle data types. So Oracle data types have sort of changed over the years, and they have been consolidated. We used to have variable character, narrow characters, large characters, international sets of character. Now we just have variable character. So, and we used to have numbers, floats, double. I don't know if there was ever a double in there, but now we just have numbers. Makes it a little simpler. The reason why is because originally they were trying to be more compatible with programming languages that support different levels of precision, different things. And then they realized, well, we're not going to be compatible anyway. So let's just go with a standard system. So it's a standard system you're going to get with all databases, same kind of format. The syntax might be a little bit different because the naming of the variables might be a little different in terms of the data types, excuse me. So we have several different date formats, character formats, number formats, and then the uses of it might be for error checking and for efficient use of the storage space. So just like you're using it in terms of programming languages, you don't want to make everything as big as possible because you're going to take up a lot of memory. And especially if you're talking about a concept like a database that's storing a lot of data, you don't necessarily want to be a hog and take up all your disk space in terms of the data. So here's our variable character 2. Why they just didn't rename it variable character? Because we had a variable character, then we had 2. So, okay. Maybe if years down the road it'll be 3 or 4. I don't know. It does make itself backward compatible, however, if you've got tables that are created with variable character and not variable character 2. But basically the variable length of the character string is specified the maximum number of characters that can be included in this particular data type. The specifying the minimum width allowed, no trailing blanks are added, yada yada. Essentially the data types are just used the same way as they are in programming languages. They define what the allowable range of values are and the allowable operations on the data type. In the old days people had really bad database design and they made everything text. And then you put a number in there and you have to take the number and you have to convert it from a text to a number. And it was a bunch of problems. So database companies decided, well, we need more variable types. And we need to make it sure that people can use them. So we have date types and text types and number types. So we can make the data itself more representative of what it actually is. And then we can check values. So it's done a lot for error checking and stuff. In terms of the example declaration, here's student name, which is a variable character, and it's 30 in terms of the length of the variable character. Just an example of how you would create one. And then we also have character. We have variable character and character. However, I haven't looked at 11G, and somebody was recently telling me that character is gone. No more character. The variable character now encompasses character. I'm not quite sure if that's true, though. I have to look at it myself. Character is a character. It's a fixed length character data. Maximum size 2,000 characters versus 4,000 characters on a variable character. Must specify the maximum length allowed and adding trailers or spaces to pad the width are used. So then we have student gender. I'm pretty sure character is still supported 1, but you can use variable character 1. accomplish a similar task, actually. So N character supports 16-digit binary character codes used for alternative alphabets. Variable character, I believe, is supposed to be storing international codes as well, but don't quote me on that either. So, and then we have number types. The reason why you want to specify the data types for your different fields is because then you can actually not have to do as much conversions to it. And what ends up happening is, especially if you create a data type that's a date, when you insert the data into the database, you actually have to put in the right type and actually have to convert the data to a date to put it in there correctly. Which is why a lot of people just use text initially. You know, everything's text. There's no conversion to get it in, but there's a lot of conversion to get it out. So it can make your database more usable or less usable, depending upon your configuration. So here we have the number data type. Stores values between this range here. It's a general data type specification where we can say number with the precision and the scale in terms of the parameters. And we're going to see examples of this when we start looking at the SQL query commands, probably towards the later part of today. So number data types, number types are integers, fixed point, floating point, specified by precision and scale, as we've seen. Precision is the total number of digits on either side of the decimal point. And then the scale is the number of digits to the right of the decimal point. So if we're looking at dollars, we're probably going to put 2 there. So here's a 2. So integer numbers, we're just going to specify 1 for the ones that are going to be before the decimal point. So the whole number with no digits to the right of the decimal point. So the precision is the maximum width, and the scale is omitted. So we say number 2, which means we're going to be able to hold 99, 0 to 90, well, 0 to 99, essentially, in there. So we also have fixed point numbers, and this is where we get the 5, 2, 5 in the front, 2 decimal points for money, associated with money. So it contains certain numbers of decimal places, and the precision is the width. So the scale is the number of decimal places past the width. So item price, number 5, 2. And then we have floating point numbers where we don't specify precision at all. Instead we say contains a variable, it will contain a variable number of decimal places, precision and scale are omitted. So we have SGPA as a number. We just put number in there, and that way we can just specify anything. It gives us less precision, but it gives us more flexibility in terms of defining the field and the data type. And then we have dates. So lo and behold, we have different date types. And if you specify a date type, it's not very standard, well, one that's odd for your database table, then every single application that uses your database table that tries to put a type in will always go, well, that's an odd type. That's an odd format, because they have to use the same format to put the stuff in. You can't take text and insert it into a date formatted field. It doesn't work that way. Which is why a lot of people just use text for that, because they don't want to bother with having to know the format. But if you know the format, then you can actually check the dates, and then you can do calculations with the queries on the dates. So here we have date that stores the date from this particular range to this particular range. Both stores both the date and the time component. So although we're calling it date, it actually performs the time as well. We can actually just put the time in or just put the date in. But most people would actually put both in just in case you wanted to use the time. So it's getting a little loud. Sorry. Okay. I just don't want people to be irritated by it. So here's a student date of birth, space date, and the dates being used without any specification on the format. You can specify the format if you'd like, however. So specifying date and time values, if no time value is given, then the new date that's inserted will get 12:00:00 a.m. So isn't that what they usually put on those alarm clocks when you lose the power? Or does it say 12:12:12? I don't know. It's just 12. I don't know where they come up with that, but somebody came up with that. So 12 o'clock morning a.m. The start of the day, I guess, is the start. If no date is given, then the new time is inserted, and the default date is the first day of the current month. So if this is, what is this, September? It's almost over with, though. October's next week, isn't it? Yeah. So if this is September, then it would be September 1st. Year 2012. Now we have another good feature of the current version of Oracle. Well, actually it's about 2 or 3 versions ago. They decided to give you this large binary object or large object of data types, or a lob. We also have binary large blobs, binary large objects, or we have character large objects, B files, and C clobs, character large objects that support 16-bit codes. What does this do? It allows you to store up to 4 gigabytes of data in a memory, in a cell. What does that do for you? Well, it allows you to create something like iTunes as an example, which is a database. You go into the database, you do a query on the database, and you say, I want this MP3 file. And you pay $1 or whatever it is the current price is right now. And you download from the cell, from the database table where this large binary object is being stored. I don't know exactly which format, but I'm pretty sure it's going to be in a MP4 or MP3 format or whatever it is, COAVV or whatever it is these days. You're downloading the file from the database, so there's only one copy of it. Everybody downloads the same file. Much easier than putting it into a file system, although it makes the database bigger. So you have to optimize the database to actually work with this kind of concept if you're going to do it. A lot of people do this for profile, for pictures and things. You can take a picture, JPEG or PNG picture, put it in the database. It's actually sitting in one of the cells in the database for the user account. And then you run a query, you say, here's the picture. You pull the picture out, and you display the picture on the screen. Nice object, nice concept. However, those pictures take up a lot of memory. So now a lot of people are putting in, instead of putting the actual object in the table, they'll put a link to the file system. And they'll say, this is going to be in users-pictures-bhacker, because that's my username or something. And then it's going to pull out my picture from a pointer that essentially that's getting from the database instead of actually loading it from the database. It makes the database run faster. Depends on how many times you're querying that database, however. So, and what you're using the database for. So if you're a big company and you don't really care, you could stick pictures in archives, and if you're a medical company, you could stick all these stuff that comes back from patient history. Put it all in the database. Then you never lose it. It's all connected with the user and the user account. So it makes a little bit of sense for that. So declaring a large object data type, a lob. Enter the size is not specified. Well, you don't have to enter the item size. So you say item image blob, item image B file, depending upon what you're putting in there. So you can put Word files, PowerPoint files. So when you create the database table, here's an example of the create table command, create table, table name, field 1, this data type, field 2, this data type. And here's an example here of creating a table called my underscore students, where we have a student ID that's 6 characters long, a name, a date of birth, a class. You can put a picture in here, call it a lob. So. And then we have constraints. So these are the constraints we looked at with entity relationship diagramming. So these are the rules that restrict the values that can be inserted into different fields. So types of constraints. We have integrity and value related. An integrity constraint defines the primary and the foreign keys. This is the one we've been looking at so far. So entity relationship diagrams give us our database integrity, which means if we have a student and the student has a student account, the student can take classes, so the integrity of the system allows registered students to be students. No integrity would mean anyone off the street comes in and signs up for a class, and there's no foreign and no primary key to link them together, and it opens up the door and makes it available to everybody, essentially. You don't have to be a student, you just come in and register, and you take a class. So integrity is retained with the keys, because then it'll look for the primary key and the foreign key will be linked up, so it'll look to make sure that there is an existence of this student in the system before it allows the registration to happen. Versus value constraints. So value constraints specify a range of values that can be inserted. Value constraints are created with the use of data types. So if I say that this is going to be a large binary object and you stick in a text file, well, that's probably not going to be a problem. But if it's a date field and you put in a text information, it's going to come back and say, oh, sorry, can't put that in here. Or if it has a gender and it's expecting a character and you put in 5 characters, it's going to go, what is this? I don't know what this is. You could actually specify default values. You can specify ranges of values. As an example, if I had a gender field, I can go M or F, perhaps, or O for other, I don't know, but usually it's one of 2. So, but it allows me to specify which one in terms of range of value. As an example, if you were a sophomore, junior, senior, freshman, sophomore, junior, senior, oh, I got it right this time, I could put those 4 values in, and you'd have to enter in one of the 4 values. Otherwise, the database would reject it. If the database rejects it, it rejects the entire row, which is nice because it'll eliminate, the constraints allow you to eliminate bad data from entering into the system. So you don't get that. So we have constraint levels. We have the table constraints, and then we also have column constraints. There's no such thing as a row constraint. If you can access the row, you can access the row. Everything in the row you can access, which is kind of dangerous, which is why people pull data out, and they'll keep it in separate tables, and they'll link it, and they'll take it from a third normal form and bring it back down to a second for security reasons, because we don't necessarily want all that stuff in there. Because what happens if somebody figures out how to get into it and can access the row, then they're going to see all of the review comments that they got from their last performance review, or they're going to see information that we don't want them to see accidentally. So if we don't want to have that ability, then we break the table out, we don't make it available. Or we create what's called views. So I'll talk about views when I talk about the SQL stuff, but so far we've been looking at the concept of the table, and the table is going to store all of the underlying data. Well, we can create this concept of a view that's really a query on the table that's going to pick out particular columns that are in particular rows, and only allow us access to those desired columns, not the entire row. So if we create a view, then we query the view, and we use the view like the underlying table, and then it restricts our access to the data. So if you don't want to pull data out of that table and separate it unnecessarily and duplicate it, then you create a view, and you query the view, and you update the view, and there's certain limitations that there are to views. Some views that use multiple underlying tables cannot be updated, but other views can. So there's certain things, and I'll go through that when we go through the view concept. But that's another way of securing, because I was talking about security, so it's another way of securing the database table. So here's an example. Primary key value must be unique for each one of the records. Column constraints, the restricting the values of particular columns as the gender here is MRF. And somebody actually at one student, and I'm answering questions now for students, but I'm addressing it to the entire class because I know it was not just more than one student or 2 students that have particular questions. So don't feel embarrassed if I mention your question. But somebody asked me a nice, good question about the differences between unique keys, primary keys, and I can't remember what the other one was. What was it? Candidate key, unique key, and primary key. And I answered the question. I thought, well, maybe somebody else in here probably has the same question. Unique keys are always unique, which means they can't match. So every record that has a unique column that's set, and you can actually put when we create the queries, you'll see we actually put the word unique in there. It means for every single row in that database, that's unique. Which means nobody can have the same number. Think of a social security number. Nobody in here has the same social security number as somebody else. So if I were creating a constraint on the table and I want to say that's going to be unique, then I would call it unique. I'd say, but if there was a case in which 2 people would have the same social security number, I wouldn't be able to put the second one in the database. The table would stop me and say, hey, I'm sorry, it has to be unique. We already have that number in the table. That's the unique concept, which is the underlying concept of making things unique. Primary keys are unique keys. They're the same thing, except primary keys are linkable to foreign keys. They have the table constraint characteristic to them, and they're used to index the table. So let's talk about indexing for a second. Database tables are automatically indexed by Oracle, and they're indexed on the primary key. What I mean by an index is not a numbering system. What I mean is a separate data structure that's kept. So we have table A, and then we have index A. And the person goes and says, I want to run a query on table A. So Oracle automatically goes to the index A and uses the index to search. And the index doesn't contain all the data. All it does is have a pointer to the real data that's in the table. Smaller search space. So for those people who have taken algorithms or data structures and stuff, indexes make the speed of the search run much faster. So if we designate it as a primary key, it's used as the index value. So, and if we search on the primary key, And we go, give me all students with social security number 123. Then it goes over to the data, and that where clause says, oh, index, here it is. Quickly finds it and moves over, goes back to the original table and says, here it is, here's the row, and gives it to you a lot quicker. If we say that that's not a primary key, if we just call it unique, and we say, give me all students with social security number 123, there's no index. Index isn't even going to be created until you have that key created. And then what ends up happening then is over here in table A, it goes through every single piece of data in there looking for 1, 2, 3. Slower search, bigger search space, slower, not as efficient. Also, if you have a primary key in one table, and then in the other table, and we're going to see this when we start looking at the SQL commands, we can say in table A, we have primary key as a social security number. In table B over here, we're going to say primary key, foreign key is now the social security number. There's a direct linkage, so when you join the two tables together, it uses the indexes. And then it can also put a constraint on it, so you can't put something into table B that doesn't match something in table A. So if you try to go 1, 2, 3 in table A, and the same student has 4, 5, 6 in table B, it'll say, I'm sorry, foreign key integrity restraint violated. You're expecting there to be a primary key over here in this table, and there isn't. And this student is not in this table, so we can't put you in here. So the database will come back and complain because the foreign doesn't match the primary. A primary key in one table is primary because it's, well, the word primary stands for first. A foreign key in another table that's not in its original first table is always foreign, regardless of which table it came out of. So it's not called a secondary key, which is a common mistake actually. But the second table that has the foreign key can have as many foreign keys as it wants. In fact, you can link together every table in the entire system and put it in that table. You may not have to. You may only have to do it for whatever it is you intend to join. So you don't have to do it just for joining purposes, but it does speed up the joining of that particular second table. And when we talk about joins, it's basically taking table A and taking table B and merging them together and doing a query on the two of them together. And if we're doing the key concept, then it will run much faster if we have foreign and primary. But it's not a requirement. We can still join them without the keys. It just runs slower. The other thing with indexing, by the way, is you can turn indexing on and off. Mostly when you're inserting data into the database, you don't want indexing on. When you're querying the data, then you want indexing on. So Oracle's funny. It will actually do it for you automatically, and it turns it on, and it sets the primary key as the index value when you create the table. Then you got to go in and say table this, index off, table this, index off. Then populate your table. Insert all the data that you want in there, and then turn it back on. Because if you don't, every single time you do an update on that table, the entire index has to be recreated. So the index will take the table insertion of the data will take twice as long because it's got to update the table and then it's got to update the index. Update the table, update the index. That's very time consuming. And we don't need indexing for updating. We only need indexing for searching. So normally you just turn the index off after you create the table, populate the table, then turn the index back on. Which is kind of funny because then you have an application where what if it's an empty table? Then you just leave the indexing on. And then if the database runs slowly, then turn the indexing off. And then, okay, so you can update it enough, but you can't, you won't be able to query it as fast. So a lot of your shopping cart applications, and they'll turn the indexing on and they'll leave it on. I guess it makes the product look up a little bit faster. It makes the order entry and order requesting information about your order run a little bit faster. But when you go to create a new order, you notice it's specifically designed with weight in mind. Put all your information, wait, verifying, wait. They'll put the weights in there, and they'll purposely design the interface so there's times in which you'll just sit there and you'll wait. You'll have to go through a bunch of screens because the database really isn't up to date yet because it's still updating because that's going to run slower than anything else. So you just design the application to take in consideration that there's going to be a bunch of updates. If you have an application that's going to do constant updates on stuff, you're not going to get very much usability if you have that index on. So which is kind of which is where you talk about database efficiency. When you get a DBA in there who can actually tweak the database, is one of the things I'll play around with is indexing. There's awful table spaces and a number of extents and stuff. So probably not till the next weekend, not this weekend, but the next. I'll talk about table spaces, storage management, indexing, which you'd think a file system, you'd think that Oracle was running off of a file system, and it actually sort of is, but it's a virtual file system. Everything is still stored in the form of files, but you have like 4 gig files, 6 gig files. All these files come together, and they give you this storage space. Because if you think of the concept of a database, especially one that would be used in Oracle, it's not going to fit on one hard drive. It's not going to fit on a 250 gigabyte or 300 gigabyte hard drive or a terabyte drive. You know, you want to have tons of data. Imagine all the email that we have out there for all the users of Gmail, not fitting on one computer. Instead, you have stacks of disks, stacks of storage space, and you have table spaces on there, and the table spaces are giving you like 12 terabytes or something, or 15 terabytes of space. And you're doing fault tolerant, so the space is virtual. That's created, it spans multiple disks. One disk goes, you pop it out, you pull a new one in, and you restore it, and you're done. And there's not like the whole thing with a computer system, like on your personal computer, if your hard drive dies, you can't access anything kind of concept. So there's a little, it's kind of interesting to see how databases manage that actually, but that'll be in the second, a little slight tangent, but that will be in the second meeting. All right, back to constraint levels. Constraint names. Internal names are used by the database management system to identify the constraints. Each constraint name is a user schema, must be unique, because we can actually put constraints in here, and we can create our own constraints. So if you do not use a name as a constraint, the system will automatically generate an intuitive name for you. So here's a constraint name and convention: table name underscore field name underscore constraint ID. So you can create generic constraints and assign them to tables and to columns to say that male and female are the only 2 options for gender, or that sophomore, freshman, junior, senior are the only options for class status or something. And then you pretty much customize the data field for you. In terms of constraint ID values, this is where the PK, the FK, the CC, check condition, the NN, and the UK for unique come into place as abbreviations. Yeah?
There's one more difference, like for primary key and unique key.
Mm-hmm.
Unique key, is it like it supports null values, and primary key never supports null values?
Neither one of them support null values. You can't have a unique key be null.
But just for one.
Actually, you could have one,
record.
you know, but the second one that comes in is not very unique. It's null.
Yeah.
However, there are some configuration changes that you can do on the system. By default, I believe uniques can be null, but you can turn it off. So when you define your database, usually you have a toggle for each one of your columns that says null, not null. You toggle it. If you put it, make it unique, and then make it null, which means that you can store null values, and then you're violating yourself, you're overriding your uniqueness, because null is not very unique. So you can never have a null value for primary key, because that will violate the concept of the primary key, and you can't index on a null. But if you turn it off, you say not null, or excuse me, null instead of not null, which I believe by default it should be not null, you can make a null value be a unique value, but you've totally destroyed the concept, if that makes any sense. But that is one of the restrictions, you're right, because primary keys can never be null. But unique keys can be null, unless you want to turn it off and make so it's not null. So usually they have to toggle between null and not null. You switch it. Oracle does, yeah?
Yeah. Primary key could be a composite key as well, right?
Yep, a primary key can be a composite key, yes.
But unique key should always be just one column, or it can be composite.
Unique keys are never composite either.
Yeah, so like this is one of the distinctions.
Yeah. Yeah, so you can also say that on unique keys they're never composites. They're single valued keys. They shouldn't be null, but they could be null if you allow it. Candidate keys are any key. Any key is a candidate key. So the way you can describe that is like, you know, when you put a job offer out there and you get 5 candidates that show up to interview for the job, those are all candidates. Those are candidate keys. But you're only going to give one of them the job, right? Hopefully. You're going to make one of them into a primary key. You're going to give them out of candidate status, and you're going to make them a primary person. And then the rest of those candidates are going to go away. They're no longer candidates. That's what the candidate means. I don't know why they actually have candidates, but they can specify candidates in the design phase. And if we're going back to that entity relationship diagram example, we could say the candidate would have been like the name, or we could have put in a fake key in there, like a studio ID or something like that. And that would have been a nice candidate too. So normally, when all else fails, you want to use values that are in the data. When you start adding more values and more columns to the table, you're making the data larger. Because some people by default go, okay, we need studio ID, movie ID, star ID, student ID, teacher ID. I don't have an ID. I don't think I have an ID at ITU anyway, though. But it doesn't, you know, defeats the purpose. But you guys have IDs, which is kind of weird. They could have used something else, right? So if you're using a piece of data that's already in there, then you have better control over the ID. Plus, you also have the ability to identify the ID. As an example, when you call in to get support, wouldn't it be better if you knew your passport ID? Or you knew your, they give you a student ID. You know how many students don't know their student ID, actually? You know, I can see it during exams when it says, put your student ID on the top, and they go, where is my student ID? I mean, after a while, you memorize it, you know your ID, but what is it? It doesn't, nothing, has no, it's like passwords. It doesn't usually mean anything normally. So it's not supposed to mean anything normally. But anyway, yeah?
So when do we create constraints at the time of creation of table?
When you create the table, you'll create the constraints.
At the time of creation
Yep.
of table.
And we'll see that when we look at the SQL stuff coming up.
Okay.
You can say when we create the table, this is a primary key, this is a foreign key. And I'll show you the syntax for that as well.
So that means we have to create that table first which have primary key. And then
You can also add it after the table's already been created by modifying the table.
foreign key we can add later.
You can update a foreign key, you can update a primary key as well.
Primary key.
Yep. And you can also add unique and null and not null to a table by modifying the table. Using SQL, actually, or using a GUI interface. So.
The table should be null at the time. Like it should not have any data while modifying its structure.
Interesting problem. Yes, although you can do it after you create the table, you're going to have a situation in which 2 people have the same primary key, and then you're going to have, oh, sorry, can't do it. And then you have to remove the data, conflicting data, and make it work. Which is another example of what you probably don't want to do. The other thing you don't want to do is add a column to a table. You've got a table with 2,000 people in there. Let's just take the student table, and now we're going to add something to your table. Car license plate number. Well, everyone who's in there already doesn't have one. Just the new people that get added in will have one. Unless we go back through and update everybody's car or whatever, registration number or something, I don't know, whatever piece of data we added to it. So, not a bad, you can do it, but it's not a good design. So, it causes problems. So, alright, so we have the example of the constraints going on here. And then we have primary key constraints. So we can actually create constraints as primary keys. So at the table level, we can say we can define a primary key by going constraint name primary key. Constraint name being the column name. I'll show you the syntax for this as well as we look at the SQL queries. And so here we have student or s underscore ID number 6 constraint. Here we have student underscore s underscore ID pk primary key. So we're using it as a database constraint. So. And here's a create table. Actually, for the person who asked about it, this is an example. I'll show you the syntax as we get into the SQL lecture. Hello. But to basically create a primary key constraint. I'll just wait till everybody stops talking. Okay, there we go. Can be defined when the field is declared. So here's how we do it when the field is declared. We say create table my students, and then we have inside of the create table command ID, student ID, and we're putting here constraint. My student ID is primary key, and we can also in the other table we can say it's a foreign key. And when we specify it as a label, we have predefined constraints that are defined in the system that say this is a primary key, this is a foreign key. You can actually rename that and come up with your own unique constraints. Why would you? primary key is a primary key. A foreign key is a foreign key. But if you wanted to, you could come up with your my key and add my key in as your constraint key if you wanted to. Meaning that perhaps, let's say for example, you wanted to use social security number, but you wanted to have a specific type of social security number, make sure that they had 3 digits by 2 digits by 4 digits, but you wanted to change it slightly to add 5 digits on the end or something. You could come up with your own constraint key that would provide you the ability to customize that if you wanted to. I don't know, or come up with a composite as an example and create that into a key. So, which I forgot to mention actually before, some of the composites can be done by entry. When you put the data in, it can check to make sure that the combination is unique. You can also make it so that when you put data into the table, it checks another and it does a test on the data to see if it's in another table or if it's an allowable piece of data that you can put in. So you can actually enforce database rules through the constraints. And you run the constraints on the table so that when you insert the data into the table, it'll check the constraint and make sure it's not violating any of those rules that you've set, essentially. So let's see, here we have it after the end of the table on the bottom, it's the last line. Here we're putting it in when we're defining the column in the table. On the next slide here we're also defining it as a definition at the end after we've completed the table. We can also add this to it on an update a table instead of just to create a table. We can update the table and add the constraint to it. Here's our composite primary keys and the syntax for that. So how would we do that? We have a constraint with a constraint name, and it's a primary key. So we were making our own user-defined constraint, and we're calling it by saying, create a primary key with field 1, comma field 2. So we're creating our own field and our own constraint that's a combination of 2 separate fields, and we're going to put them together, which is the composite. To do that, you must define after the field that composes the keys are defined, you have to put the constraint in there. So here we have down here constraint enrollment underscore s underscore id underscore course underscore id underscore pk. Primary key is going to be student ID and the course ID. So we can make a composite to link the 2 of them together. We would do this in the case of the health insurance policy for the dependents and the employees. If we did this, then in each one of the employee table entries, we would have a composite, or we can also do it in the dependent table, a composite that links the employee ID with the dependent ID. And then we could key that and then query that and remove all of the dependents. So we would solve the problem with the dependents by doing that. It comes in handy to create composite keys when no key exists. And when no key exists, then we want to do it this way. This is going to take longer because it's checking 2 values and putting something together on each insert. The best way of doing it is just to have a regular old primary key. If you do too many composites, you're going to slow down the efficiency of your database, long story short. Foreign key constraints. We actually say that this is a foreign key. So as at the table level, can only be defined after the field is defined as a primary key in another table. So now you go, well, what does this mean? When you put together your table creation technique, and you're usually just going to write out all the SQL statements, you're going to put it in a text file and just run the text file, which is the easiest way of doing it. Create all your primary tables first, and then create all your secondary, or your, all your foreign tables second, so that you can link the 2 of them together. Because it's not going to know which table you're talking about, which key you're talking about if it doesn't exist. So here's the syntax on the constraint name references. We have a primary key table, and then we have the field name. And this is going to be the foreign key, or actually it's going to be specified as references. So here we have it. It can be defined when the field is declared. So we have the advisor ID number constraint is going to be on this long field here, and it refers to the faculty ID of the faculty table. So it's the table name plus the field that's in the table that's being referenced. So we use the word references to create the foreign key. We can also use the syntax foreign key, actually, and call it a foreign key, and that creates the reference for us automatically. We can do that because foreign key is a predefined constraint. Same as primary key, it's a predefined constraint that we've created. So here it is, here is the word foreign key is being used. So the foreign key constraint that gives us, or can can also be defined after the table has definitions are done. At the end of the table here where we say foreign key is advisor references, primary key, which is going to be the faculty underscore FID. So different syntax accomplishes the same task. One uses a key constraint, the other one uses references, creates a key constraint at the same time. So value constraints. Just when you thought there was no more constraints possible in the table, no, well, actually there's more. We have column level value constraints. So it restricts the data that can be inserted into a field. So avoid value constraints because they make the database very inflexible. So if the value constraint says you need to put red, white, and blue in there, red, white, or blue, and you put pink in there, or you put light blue, or cyan, or something, it's going to make the database very inflexible, very hard to put a color in there if you put a constraint like that. And this would be a value constraint, an example of a value constraint. They're putting on a column that says it must be red, white, or blue, not cyan or pink or any of those other combinations. Makes it inflexible, makes it unusable. Because you have to check the value before the row will be inserted. If the value doesn't work, the row can't be inserted. So it checks on a condition, it restricts to specific values. So here's the example for gender, male or female, M or F. So it's going to do a check, and here's the constraint on my student's gender, check, and we use the keyword check that says check to make sure that this field is equal to this or this field is equal to that, essentially. And we create this and then we apply this and we can reuse it on all of our tables. People who don't use constraints use the application front end to control it. Never do that. If you let each web application out there control everything that's happening with your database, you're going to have a lot of inconsistent data in that database. A lot of uppercase, lowercase, a lot of dates in the wrong formats, weird genders, weird colors, weird everything. So the more constraints you put on the database, the harder it is to put data into the database, but the more consistent that data is going to be and the more workable the data is going to be in the end. So those people who let the front end do all the work end up regretting it eventually down the road. And what ends up happening is the database person, the admin person who's followed all these strict rules, has configured this database, and it's their little baby, it's sitting on their server and they like it and everything's cool, and then application programmers come in and criticize it. How come I can't get my application to work with your database? And then they pressure the database person to open it up, take away the constraints, make it more flexible. This is not very flexible. Well, it's not flexible for a reason. So then the DBA breaks down and says, all right, we'll just make everything text. So we don't have to worry about date formats anymore. Okay, let's take away the primary key. Okay, let's do this. And then all of a sudden you get a lot, the application developers are doing whatever they want. You got garbage in that database, and then you've gone downhill. But so the database person, actually, you have to take all the flack, because you have to go, no, I'm sorry, I'm not taking away that constraint. It has to be an M or an F, and it has to be capital. So you make your application, give me the data that's correct. Which they don't want to do. They just want to, they just want the easy way out. They just want to put the data into the database. They don't want to make sure. So now we have form checking, which is nice. Form checkers are helping the database person. Form checkers fill in autocomplete. Nobody has to type in the state anymore because people misspell states or even abbreviations. You just have drop-down lists. Makes the application developer's job easier because it's abiding by the rules of the database without breaking the database rules, essentially. Here's our not null, specifies that a field cannot be null, not null. So we can put the constraint on it. So here's a constraint for my student underscore date of birth, not null, which means you have to put a date of birth in there. You can put a not null on a unique. There's no reason to put it on a foreign key or a primary key because it's already going to be not null. So it's kind of redundant if you put a not null on it. The values of the types of the value constraints. We have default. So we can put a value constraint on that specifies a default value for when the user doesn't put anything in there. This is to eliminate something from being null and also eliminate the possibility of bad data being put in or no data being put in. So default specifies a default value that's inserted automatically. So if I were to take your student table and add vehicle registration to it, I would put in a default value like not given. The word's not given or something. So that everybody in there who didn't give it is going to say not given. That way I would know that all of these users here, all these students, were in the system before this constraint was given and before this column was created, commonly used for that. So what ends up happening is when you call in for support somewhere and they say, okay, what's your customer ID, and they find you in the database, then they say, do you have an email address? Because they're looking at your field and it says not given, not given, not given, or unknown, unknown, unknown. Because they created all these fields. Maybe you signed up with this company like 10 years ago before email was popular. Now every company's taken email addresses, telephone numbers, all this stuff. You know, your system is probably, your record is probably empty. Probably has not given, not given. So they ask you, oh, can we update your address? You know, and usually I tell them no. I don't have email. No, I don't have phone number. No, I don't have any of that stuff. They go, oh, okay, because I wanted to say unknown. But anyway, long story short, you'll see it as a user because when you have the default values that get put in, it's usually a red flag that, hey, the user didn't survive, that's missing. You need to ask for it the next time that person calls in, kind of thing. Unique here is a table constraint specifies that a non-primary key field must have a unique value to it. It's not normally the primary, it's a non-primary key. And you use the keyword unique, so you can't have an email address that matches all over the place or something, or a telephone number that matches. So here's that little SQL Plus window. Here's the login for it. Actually, we don't get the login anymore. This is very old. This is like Windows 98 or something. So very, very old, archaic kind of window. Now we just get a type in connect space, and then you have the window for it. All the commands must be terminated with a semicolon if you use this window. And you can use a text editor and copy and paste into the window. And characters data is case sensitive as well, must be in single quotes. Here we have M, which is a capital M, Sarah with a capital S, Sarah there. When typing in SQL Plus, we can type in exit to exit, which is kind of interesting. Until you exit, you haven't committed yet out of this window. This window has an auto commit. If you turn the auto commit off, you can go into the window. Whoops. Oh, where did I go? Well, this is weird. Go into the window. Exit the window. I think I rested my hand down on the keyboard. You can go into the window, make all of the changes in the window, forget to type in exit, and then everything you've done hasn't been recorded. Not such a good idea, especially if you're logging in remotely, because then you can't go back in and like open up the window again. You get a different session, so you lose everything. Which is why Oracle put an auto commit on that window. Which means unless you change the defaults, you'll be safe. You don't ever have to exit out because everything you do is automatically committed. So you'll have to roll back if you want to undo it. Which is kind of the safer way of doing it, I believe. So we also have Oracle help resources that you may have found already that exist out there. In fact, they're under the Sun site, but the old Oracle links still work, actually, which is not too bad. This is probably some of the worst help out there, however. If you've ever looked at Oracle documentation, you see a bunch of codes with a bunch of explanations for the codes. And it's like, I don't know, if you were to print it out, it would be probably about 2 inches thick, paper printed on both sides of the page. Not very user-friendly, written in Greek, very abridged, no explanations, nothing. So when people get into this, they usually buy the certification books, which are actually pretty good, because it leaves out all the explanations and stuff and just tells you what the feature is, because that's what you're supposed to memorize for the exams. So if you're looking for a good Oracle book, look for the certification exams. The books is the exam series, not the How to Learn Oracle in 21 Days. Although, I shouldn't say I haven't looked at these books in a while, but some of them have basic database stuff that's going to bog you down and you just want to know about Oracle and you don't want to know about basic database stuff. So the certification books usually are more pinpointed towards Oracle features. But they kind of read like exam prep books. But maybe after you get done reading the exam prep book, you go and take the exam. And then you'll be certified as well. So, alright, so viewing the table information, one of the SQL Plus commands, as I mentioned before, is the describe. Well, I didn't mention it before, but the describe command. This is not part of SQL, but it's part of SQL Plus. So you type in describe space the name of a table, and it will actually here describe my students. It'll actually tell you what's in the table. Not an SQL command, but an example of an SQL Plus command. We also have the Oracle Data Dictionary. This will help you with some of the assignments. In fact, it'll probably help you with the next one that we're going to do as well. We have an exercise coming up in a few minutes after we take a break that is going to ask you a bunch of Oracle questions again. So this lecture can be used as a reference as well, and the main concepts as well. But in terms of the Oracle Data Dictionary, contains the tables that describe the database and its structure, is called the system user schema, which we actually had from the last exercise we did. System is where that came from. Automatically updated as the user creates and modifies tables. This table actually keeps track of all of the user tables and all of the user components as well. And cannot be updated directly. It's updated by people using the system, which is kind of interesting. Contains the views that allow users to retrieve information from the database structure as well. And in terms of the database dictionary views, the views represent the data that's from different formats depending upon the privileges of the users. So we have a user, an all, or a DBA view. Depending upon the DBA view, the user, the all, you can have different log files, different control files, and different things that you can actually see in the system that's being recorded and tracked by these user tables. The system tables, everything is stored in a table. So in the system tables we have different properties, different columns of different information. That was what the purpose of that first exercise was to go through and kind of explore the concept in terms of what's available. When we're looking at the user, in terms of the data dictionary, it shows all the objects that belong to a current user. All is going to show all of the objects from the current user as well as the objects that the user has privileges to. So you can actually see what the user is looking at and view from multiple different perspectives to get a feel. So here when we're querying the data, which is kind of interesting, system admins query system tables. So you can get the current system date from dual. You can get number of users from users. You can get profiles. You can actually query, run an SQL query to see how many people have this privilege, who has this privilege, and run and get all of the information you need about entirely everything you're going to do. So here we could select this field, that field from privileges _ view name. So we can query the privileges and the names to get the information that we're looking for in terms of the system table. Here's a summary of the Oracle Data Dictionary views. We've got objects, tables, indexes, views, sequences. What is a sequence? We have a global sequencing system. The global sequencing system, and think of this sort of like a checkbook. Actually, think of this like an ATM. There's a global sequence of numbers. Every time anyone goes to any ATM machine in the Cirrus network or in the whatever star network, whatever network you're on, you're given a unique sequence ID for your transaction. So we can go back and say this transaction, number 111259 whatever, from a sequence was done in San Jose, California at 2 o'clock in the afternoon by this particular user, this card number, transaction lasted this long, and this user did this. All the information is tracked. And it's a global sequence that's stored in a system table that's used and queried. So when the entry is updated, when you go in and you log in, even if you don't do anything, it pulls the current sequence number and attaches it to your transaction. And you can actually get a receipt even though you didn't do anything because you have a sequence. You have a sequence number. It's a way of keeping track of things. It's kind of like the checkbook registry, where each check and each transaction in your bank account actually has a number associated with it. If you haven't noticed, if you go online and you do something or you send an electronic payment, there's always a fake check number associated with it. Or if you have an auto payment set up, you have a fake check number and then you start the numbering sequence. It's another sequence concept. It's so that somebody somewhere along the lines can keep track of what you did. So that's what it means, the same thing in the database. The database actually creates and manages the sequences for you. So you don't have to do it outside of the database. It's inside of the database as a feature. Users, constraints, tab columns, index columns, all sorts of different things that are available from the database view. We can also modify tables. So once we create tables and we decide we don't like the table names, we can modify them. We can rename the tables. We can add new columns to the tables, increase the column size, drop tables, drop constraints, make things easier. We can also, and I'm almost done, so hold on. I know some people, it's like right after lunch, so some people get antsy and about right now. So I can sense the room, we're getting antsy. So don't worry, we're going to have a break coming up. I just want to finish this lecture. We have restriction actions. that can be formed: dropping tables, changing column names, decreasing column sizes, adding constraints. Here's an example of adding a new field. So we alter table, add the field. Some things you may not necessarily want to do in nature because they're going to cause problems with the database. Some things, there's a lot of features that you can use that you probably don't want to use, or maybe not in certain combinations. Modifying an existing field, alter a table, modify this field. Deleting an existing field, deleting a table, drop a table, all sorts of different ways of manipulating the data that's being stored in the database. So, as promised, we're going to have a short break. So let me kill this video. Stop cap.